Assalamualaikum. My name is Samreen Zara, registration number 21PE103. Today I am going to perform the lab number 6 of digital signal processing, which is about discrete Fourier transform properties and FFT. So now moving toward the lab objective. So the objective of this lab is the representation of discrete time digital signal into Fourier frequency domain via FFT, resolution of a spectrum, computation of a magnitude, phase, and power spectrum leaking, and avoiding the spectrum leaking. So now first of all, by performing the lab task number 1, which is about writing a MATLAB program to validate the above given decimatation program. First divide the given signal into its input and output signals, then calculate its DFT of for even and odd samples separately, and then merge the both the signals. So moving towards its MATLAB code. So here I can set my original signals, describe its decimatation factor, that is 2, divide it into its even and odd parts, calculate its length of even and odd parts separately. By using the merge formula, we can display our result. Now after run this program to see the output, here the output is showing the original signal, decimated signal, and reconstruct our original signal into the frequency domain. Now moving toward the task number 2. The task number 2 is about check the above program for the given signal. Here are the 8 given signals, and we can check the symmetry of these given 8 signals by using the FFT and DFT programs. Now see its code. There is the output signal, that is set my output signal, set the decimatation factor, separate its even and odd parts, calculated length of even and odd part by using the merge formula and using the display commands to see my original and decimated signal. Now run this code to see the output. So this is the output of our given signal. It is showing the original signal and decimated signal, the DFT of X1 signals, and the decimated DFT of the X1 signal. So both the decimated of both original and X1 signals are the same. So this is showing the symmetry of all these 8 signals. Now moving towards our task number 3. Task number 3 is about check the program in the task number 1 for the signal given below and compare it with the standard functions. So these X and Y are the given signals. Here is the code where X and Y are the given signals, its decimated factor M2. Similarly, we can separate its even and odd parts and calculate the DFT of even and odd separately. By using the merge command, we can see the output of the required output. So this output is showing the DFT of X and decimated DFT of X and Y, both X and Y signals. Now our next task is task number 4. We can we can calculate the DFT of 2 samples, and then these 2 samples are added to the 4 samples, and 4 samples are added to 8 samples, and so on. Similarly, we are performing our Radix2 method on the MATLAB. So see the MATLAB code. Here is the MATLAB code for the Radix2. This is the MATLAB code for the Radix2 method, which is using the FFT and MATLAB FFT functions. So I can run this program to see the output. So there is the output of this. My FFT function is the original signals, and MATLAB FFT is the function that is obtained after performing the Radix2 algorithm. The task number 5. Task number 5 is calculate the fast Fourier transform using the on function that is used in the task number 4, and compare it with the standard function of calculating the DFT of the following signals, and W, X, Y, Z are the following signal. Now let's see the code of task number 5. Here we can define our all 4 signals, calculate it FFT of these custom FFT of these 4 signals, and then calculate the standard FFT. By using the display command, we can display it custom and standard FFT of our given signals. So run this program to see the output. So command window, is showing the result of FFT compared my FFT compared with the FFT. So this is showing the customized and standard function of my signal Y and signal Z. So this is all about task lab number 6 of digital signal processing. Thank you so much and Allah Hafiz.